Right, thanks for coming to my talk, even though there's key signing and fun stuff on elsewhere. So I was going to go to the key signing and they clash. So I can't quite get out of this one. My name's Kieran. I work in a company called Ideas on Board. We're a small company of 7 engineers. We are growing and trying to make cameras better through growing. And in late 2018, we created a project called Libcamera. We're all pretty much from a background of kernel development and multimedia subsystems. So most of us have worked in v4l2, Linux Media on Media Controller. Laurent, who started Ideas on Board, he wrote the original UVC webcam drivers. So I kind of piggyback on him because he started cameras in Linux. And hardware changed over the recent years to make cameras more complex, which has involved changes in the software stack. And that's what I'm here to talk about today, or rather, the application side of that. So I'm going to go through what has made cameras complex and what complications that has caused to arise. A quick look at some of the existing solutions that already work with applications that already work with Libcamera. A bit about the community support that is already there. So we do have people using Libcamera on their projects, and I'd like to see more. I know there's even people in this room that have got Pine phones and things that would like better camera support, or laptops with ARM devices that need improvements. On finally to future developments of where I think we need to go with Libcamera and things we need to get done, and finally Q&A. I keep that in from a previous run of this, but I do talk about lots of projects that are not things I've worked on or created. I'm just referencing them. So I've got lots of logos and certainly lots of work that are other people's contributions and efforts. So unless I specifically said I did this, I don't want to take credit for things that other people have done on this talk. I'm really talking about the whole ecosystem of cameras. So I want to start with why it came to be, why Libcamera. And thought I had more slides, never mind. In the original world of cameras, it starts out with the original camera that you'd be aware of is a UVC camera, a USB camera that plugs in with a single device node. So you get a single interface for v4l2 that you can talk to. And applications are really happy with that because they know how to get a picture and it's ready for their use case to have a video call. But cameras started to get more complicated when they moved away from smart sensors to raw sensors and biosensors, where you have lower power, lower cost, and more complexity is moved to the CPU. And part of that process started with SOC camera interface, which was a driver framework that started in v4l2. But the benefit there was you still ended up with this single video node. So applications could still use that. But it didn't scale. And then when the Nokia phones and ARM devices, in quite a majority, grew, they have so much more complexity in the features that they expose. Looking here, we've got multiple components for getting the data from the sensor into memory, for resizing it, for operating a lens to control the focus. Then we have a specific way to control the sensor itself. The sensors have their own device drivers, and you have to program the registers. We can have the ISP that can have both input from the sensor as well as memory-to-memory devices, so you might read from memory. And all of this complication ends up with an interface in Linux Media called Media Controller, which lets you create all of these entities and plumb how all of this data is supposed to be routed through. And obviously that is a lot more complexity than just talking to one single thing. Applications can and do choose to identify all of those devices, link them up correctly, and open each one and configure them correctly. There's applications such as on the mobile phone space, megapixels, who do this. But it doesn't scale once you try and go beyond a generic implementation each platform is going to be a different configuration of this graph. It's going to have different features in each of those entities and different ways of configuring it. And there's more than one application. You don't want to redo all of this knowledge about the platform in Chromium, in libWebRTC, in your camera app, in Cheese, in GStreamer, in Android. So we created Libcamera to try to make the world a better place, I'm sure. And we try to fill that gap by having various layers within the project. Specifically, this pipeline section is a platform-specific layer where ideally vendors, the silicon vendors who know their hardware, can write code that will support that device. And on top of the platform layer is the application layer, where we already expose integrations to GStreamer, to PipeWire, to Android. We have a v4l2 compatibility layer for to try and ease existing applications to be able to use Libcamera. And to make this easier for vendors, everything below is supposed to be common. So we do lots of work that is going to be the same on whichever platform you use. Any device that wants to talk to v4l2, we've got classes to talk to those device nodes, to talk to media controller, to have events, to have threads. So we've got all the abstractions within Libcamera to help in that situation. And finally, underneath at the kernel layer, we expect there to be drivers from the vendors to support the hardware. So that's the stack that we've tried to build and design and tried to make it flexible so that vendors can make their cameras work, not just with a custom stack on every vendor creating their own stack, in a way that can be used by everyone. Complications, really, I mean, it has been a bumpy road already. v4l2 is, I don't want to say old, but it's mature. It's been around since early 2000s. It was merged into the kernel in its kind of current design in 2002, and Hans and Mauro, who are the kernel maintainers, have been working on it since 2002, 2003, I believe. So it's very well used, widely supported by lots of applications. It's where developers go to get a picture from a camera. And more than camera, they've got, it does support a level of complexity for other devices like digital TVs and set-top box. And of course, it does exist already, which makes it a very go-to approach for any application developer that wants to use a camera. And so, yeah, of course, it's used everywhere, from browsers, camera applications that exist, the multimedia frameworks that let you build applications on top. I would have loved to put FFmpeg in there as well, but it broke my symmetry, so sorry if there's any FFmpeg developers. If there are anyone who works on FFmpeg, please talk to me. I do want to talk to anyone who works on FFmpeg. And of course, crucially lately, video conferencing. This is quite often handled by libWebRTC. I've seen that very commonly. So throughout all of this stack that you can see here, every application there uses v4l2 currently. And my title is Not Everybody Loves v4l2. What I believe applications like are video zero. v4l2 as a subsystem is big. It's got lots of already existing complexity, and that's kind of the hard point. Applications like to be able to say, open this device, give me a picture. Perhaps say, give me a picture that is a 1080p picture or a 720p picture. That's what they want. Make it easy for applications. But beyond v4l2, or within, we've got, as I explained, media controller, sub-devices, video nodes. You might have multiple video nodes, even on UVC USB webcams now. There's 2 video nodes, and that threw camera applications off because they thought, oh, I open video 0, got a camera. There's another one, there's video 1, that must be it. Oh, it's not a camera, it's still part of the other camera. And that confused a lot of applications. And then beyond into our complex camera scenario where you may have a CSI receiver, and this is where Libcamera is really built around, where you have to manage the data flow going from an external component from the CPU into the CPU. You don't have USB. There's no automatic detection. And you have an ISP, a whole complex block to manage and process. So to do all that, we've now got extended software that is required on the CPU for 3A algorithms. That's handling auto exposure, auto white balance, auto gains, and a whole lot more, autofocus. Everything that you expect the camera to do to give you a good image. YUV sensors that would do this within the sensor are becoming obsolete because of mass market forces from mobile devices ultimately. And now we've got laptops that are using this technology. We've heard about the Lenovo X13. There's devices with an IPU3 that are being built from Intel that use this technology. And currently, the advice is, I'm sorry, the camera won't work. And that's not a situation I want us to be in. There's embedded devices like Raspberry Pi, NXP, Rockchip, and many more, which already use CSI cameras. And all of this needs additional software that hasn't been available. The other area that I've come across, particularly with the Ubuntu community, is the more mobile phone solutions for open source software on phones, both with UB ports and the other projects that run on PinePhone, for example, and Libcamera. So v3l2 hasn't been enough, but now with something new, applications, the last 20 years of application development have been using v3l2. Nobody wants to change. Certainly they don't want to change. I know that very well. They've made that loud. So we've created this library and project to help try to provide a solution that can be common and generic. But applications now have to make changes, and that's going to be difficult. And so we're feeling a lot of resistance. We have developed Libcamera in C++. And I remember the first time I went to C++, that plus, those two extra characters are scary. If you're a C developer, you're like, sorry, what? Don't get me started on templates, I hate them. Anyway, and a lot of developers are saying, well, how do I talk to the application in C? I'll get to that later, but we have now got someone working on C and Rust bindings, which I'm very happy. That's very recent, so I added that. Just discussing then with one of the canonical engineers, we haven't ever historically declared a release or ABI stability because no one has come to us with all the use cases. What do we actually need to get to make this API right? So we need people to get enough mass usage to make sure that we get the API right before we can say it's done. So we haven't declared ABI stability, and I'm now hearing that that is also preventing people coming to us. So I think we need to have a solution there. And yes, there is an obligatory XKCD for everything. There are lots of existing camera stacks, and that is why we want Libcamera, because if you run an NVIDIA device, NVIDIA will give you a software development kit to run the camera. If you use a Qualcomm device, Qualcomm will give you a software development kit. Every vendor will give you a different one. It's time for a 15th one to rule them all. So, we do already have Libcamera running on platforms. You can use it, it works. I'd love for vendors to come to us and support more platforms. We do have GStreamer elements already existing. So again, it means that a vendor who supports Libcamera doesn't have to write a GStreamer element. We do that for you. And you can do network streaming and take all the advantages and goodies of GStreamer to do encoding, streaming, even manipulation of the images. Raspberry Pi have been working with us pretty much from the beginning. They knew early on they needed something new for cameras because it was very limiting that if someone wanted to add a different camera to Raspberry Pi, it had to go in their firmware. They didn't want that. They wanted it open so people had more control over their cameras, and Libcamera has provided that. We built up Python support. This was very desirable from the Raspberry Pi community, who all worked with Python, and nobody wanted to work with C++. And I love this. This makes it so easy to work with the camera data. I mean, Python is just kind of short and sweet, and there's helpers that have been built to make it really quick to get an image from a camera. And I was at Raspberry Pi offices, and Dave whipped up in about 5 lines of code away of doing a very rudimentary HDR merge. And I was so impressed by how much he could do in so little code. Of course, one of the key requirements for Libcamera was about making sure we have multiple platforms, and we do have an implementation of an Android HAL. Again, means the vendors don't have to write an Android HAL. If you get the platform support, all of the functionality that Android expects is built on top as the application layer. So this is my little Lego man in front of my Chromebook at home that uses the Android HAL. We have a layer to wrap applications using LD preload. The idea there is that an existing application that would normally open a single video device node, we're going to intercept those calls that would look like v4L2. We'll do the right thing in the background to then make it look like it's still v4L2, but you're actually getting Libcamera. That needs a lot more development, but again, we need users and testers to help push that development. The one thing I would say is I've made a little script called libcamerify. So if you do find yourself working on a Raspberry Pi, for instance, and you want to try a different application, it doesn't have Libcamera support, just run libcamerify your app, and it should wrap it into Libcamera. We're not application developers, though, so we've made some test applications to try and test our code and develop it. So we've got a couple of test apps for graphical visualization of the frames with QCam, and we've got a command line tool which is supposed to, we call it the Swiss Army knife of cameras, because it lets us poke around all the parameters of Libcamera. And these are displaying test patterns from the kernel. There's nothing special there. There's an application that my colleague Jacopo wrote called SimpleCam, and we wanted to make a overly documented example of how do you talk to Libcamera. And so this is a great place to start if you want to actually use the native C++ API. And we try and really express as much as we can about what the code is doing. And that can always be extended if anyone has more questions on that. And all it will do is, when you compile it, build it, it will look for a camera and capture frames, but it doesn't display them, I'm afraid. A really interesting development that has been built on top of Libcamera, particularly relevant to Ubuntu with desktop use cases, is PipeWire. We've been working with PipeWire guys for quite a while as well, and they, again, created support early on, an integration into Libcamera. Please excuse the colors there. That was a format misconfiguration, and this was actually done back in May at an event, and I can see one of the participants was there as well. Are you in the picture? Are you in the picture?
Yes.
Yeah, there we go, excellent. So I'm glad you can see, oh, top corner there? Yep, and I went to that event with one goal. I wanted to make Libcamera work through PipeWire into a browser to make a video call. And that was the very first one that worked. So I took a picture because I was happy. That was Friday afternoon at the very last minute as well. So what that means is that now we've got the integration layers for applications for PipeWire, or for Libcamera to PipeWire to WebRTC into the browser up to your favorite video conferencing tool. So that layer is now possible. And in Dublin, I think that was a month ago now, I set up a demo where I had a Raspberry Pi on one side, my little Surface Go 2 on the other, and they had a video call between each other, and you could see the video from each one on the opposing screen. So I thought it was a fun demo to show that we can now make video calls on devices with complex cameras with just this was with a self-built version of Chromium and libWebRTC to support the PipeWire integration, but it's work in progress, and there's a company called Pengutronics who are really pushing that upstream. So I expect the PipeWire integration to make it into Chromium releases. There were a few bugs for format configuration, which is why the picture colors were wrong on the previous image, but they'll get sorted out. And PipeWire at the desktop level is really also providing a lot more functionality that Libcamera doesn't want to. Libcamera, it's just not in scope for Libcamera. Things like permissions and deciding if you're allowed, if your application is allowed to look at the camera. If you have a mobile phone, if you install a new application and it wants to look at the camera, I think you have to press, yes, I want this application to look at me. And so PipeWire will bring in functionality to have permission, application-specific permissions on devices. And so I'm really happy to see that PipeWire development on the desktop. And that works with a camera portal. And So now we're almost dependent upon the integration of applications to use PipeWire. But that is in progress. This is Open Broadcast Studio working with PipeWire into Libcamera to give a camera feed with 2 cameras, in fact. And this is Christian doing a demo of it working. So I'm really pleased to see this is all happening now and expanding the coverage of the application support. So it is moving fast. In terms of community support, this is where I'm looking for, this is kind of my call to action. If you have a device and you want your cameras to work, I want more people developing and build up a bigger community for Libcamera, because we're a small team, we can't do it all ourselves. There's so many times I get requests of, hey, can you make my camera work on whatever? It's like, well, you know, you're the 30th person to ask me that. It's like, we're getting there, but we need help. So particularly here, I was just in the Papa demo room next door, seeing what Ross can build. And I believe Ross ultimately is going to integrate into OpenCV and handle like how you get images through there. So that is already working, but I'd love to hear what other integrations people are going to build on this. So I just see it as vital that, especially in ROS type environments, you're going to be on embedded systems like Raspberry Pi, and good camera support is going to be crucial. OpenCV kind of builds in on, is one of the key parts of that, and we do have it working. There's Python examples that should be merged. So this is my colleague Tommy using a Python application to capture through Libcamera and then run it into OpenCV. The libcamerify concept I told you about, even that can work through OpenCV, but there's still features missing that I'd like to see completed. There's applications like Motion. I found this one interesting because there were people who contacted me, or us. I keep saying me because I end up being the community support help for Libcamera, but it is the whole team. So they contacted us and they were asking for help. And again, this is the C++ became a problem for them. That Motion maintainer said, I don't want anything to do with C++. He then pointed me at, by the way, I have this other project called Motion Plus, where you could, okay, thanks. So I would expect to see Motion Plus perhaps have direct Libcamera integration. And you know, once these C bindings get completed that someone's working on, then that will help as well. Or perhaps that might end up going through a PipeWire layer. For something like Motion, where it's going to be really about installing a dedicated device to support cameras, I expect devices like that probably to want to talk directly to Libcamera. I like this one because it's dear to my heart, because I have a 3D printer at home and I like to see the picture and see what it's printing. And so I run Octoprint, and it had a Raspberry Pi with a camera connected to it. So I became one of the users that was screaming at me because suddenly there's no support for the camera on that platform. Obviously I'm in an advantageous position to fix that, but Arducam make camera modules for Raspberry Pis, and they, on their own, which was great, took the MJPEG-Streamer, which is used by Octoprint, and made a fork of it to support Libcamera. And I think that's fantastic. That's exactly what I want to happen. But now I have to figure out who's going to take that fork and put it into upstream MJPEG-Streamer and make it actually usable. So there's always more development. Arducam are actually making a lot of cameras for Raspberry Pi, and I think that also highlights one of the benefits of Libcamera for me, because I will always scream as loud as I can, but Libcamera means that you can take any sensor and run it on any platform. I love the fact that Arducam can now make cameras for Raspberry Pi, whereas before they wouldn't have been able to. They could only make clones of existing Raspberry Pi cameras. So on the old system, Raspberry Pi supported 3 cameras in their firmware. To get a 4th camera, you'd have to contact Raspberry Pi, they'd have to rebuild their firmware, you'd have to get a closed source blob. But now, Arducam can support, and there are many other vendors as well, can support new camera modules or third-party integrations directly on a Raspberry Pi, or an NXP, or a Rockchip, or an Intel IPU3. That's the whole point, it's any platform that is supported. So, help wanted, of course. Like I say, I want to try and help build the community of people who are interested in cameras, so I'm pleased to see you all here. I did want to highlight some notable mentions. TwinCam is almost a fork of our CAM Swiss Army knife. that a guy called Eric at Red Hat took to create an automotive use case. So he's got that integrated into a fast boot system where it boots up fast, uses Libcamera to get images of from the camera and get it on screen, I think under 2 seconds for automotive use cases, which is great. There's projects that I know like Constatus where it's taking cameras and putting it into a streaming system for like home DVR. RTSP Simple Server is one I tried recently and is really helpful. They've now got Libcamera native implementation. So if you run on a Libcamera-based platform, you can take this streaming server to capture images and send it over an RTSP or WebRTC stream. Upcoming megapixels for the phone enthusiasts. There is a fork of that called millipixels, which can use Libcamera. But I'd like to see better camera application support for those devices. So again, if anyone's working on this, this is me. Please talk to me while I'm here at the conference. We have an IRC channel, which is bridged to Matrix, and we have a mailing list. So, future developments. To get where I think we need to be, we need to have application maintainers understand that yes, there's a change, there's a burden now on code maintainers, application developers. And I love this picture because it's what I feel. I'm trying to drag this puppy along. And to get over this resistance, I need to find a way to let application maintainers and developers understand why. Why am I giving you all this pain? It's because of the way things are in the development of the cameras. It's not suitable for the long term. So I do want to give a good vision of how we can make it better, and that's Libcamera's goal. And the steps to make it a reality are, there are existing examples to help you make changes to your application, but I'm afraid we just need to work to get that development done. So I hope that the more I promote this, I can explain to people why this change is occurring. There is more development, as I said, about desktop integration, and that is happening, which is great. So the WebRTC changes are going upstream for PipeWire, which means that video calls will suddenly just start working like magic, and I hope not to regret that statement. But as I said, Pengutronics are working on that actively, so I see that as happening. If anyone wants to look into the patches, then they are public. This is the GNOME Camera app, which is a blueprint design, I believe, from somebody called Tobias Bernard from the, I'm going to say it wrong, so I'm not going to say it, but one of the mobile phone organizations that is trying to design and build open source platforms. And again, what I want to see is this application running on Libcamera or PipeWire to make these open source phones have a functioning camera support. The other reason I highlight this is because I'm not an application developer. I've started at low-level assembly drivers in the kernel, working my way up. Honestly, I probably don't have the skills to develop an application like that. So I'm looking to developers who have come the other way and are doing application development. And I hope we can meet in the middle somewhere. This is very recent. We were discussing earlier that Libcamera is under active development. We push patches every week, possibly even every day sometimes. And so our master branch is constantly rolling. And people have come to us and said, well, what version do we use? Packages, distributions have said, what do I put in my OS? It's like, the latest. That's always been our answer. And nobody likes that answer because they want to know, okay, but now what version? It's like, well, the latest. So distributions were screaming, and I mean screaming at me for a tag. And the idea that within the team we were sort of saying, but we're not trying to say this is a release, we're always changing it. But I fought this battle and won within the team that we do need to try and declare some sort of stability points and say, okay, now use this. These are the features that have been added from the last release to this. And I think that does help. And it also means that applications can say, I'm building against this version, and I know what that is, and I can be locked against that. So it helps to progress the development. So as of about 3 weeks ago, I tagged version 0.0.1. Very specifically, and people have complained on Hacker News, why did you do 0.0.1? And I did that because I wanted to highlight that it is going to change rapidly. I want to make sure that if we make an ABI change, I want that number to be bumped up automatically. Any release we make currently will have an SO name change, which means that the packages can handle linking differences. But when I've got tooling in place to say we've made an ABI change, we're not declaring ABI stability until we have a version 1, but at least with automatic tooling, I can say that will be the minor version number. So currently I'm just on a time-based window, I'm just going to bump the patch release until we can get there. The other thing I think we need is a lot more CI. We need a lot more testing. Currently, most of our testing is done by me at my home lab with some Raspberry Pis and a Chromebook and our unit tests. We need to, I don't scale, so I think we need better infrastructure, and I think we're going to probably try and move towards free desktop hosting where we can use their CI infrastructure and that people can push and we can get automated tests, which probably will still then remote control boards in my lab or other people's labs, but it needs to scale. So we are now making releases. We are trying to build up infrastructure to support the use cases. I've no idea what the time is, but I do want to say thank you to specifically this week Canonical, who have sponsored my travel here, so thank you. A whole host of companies have been working with us on Libcamera along the way. Google have kickstarted the project really with development on Chromebooks. They really want an open source camera stack to manage their cameras on Chromebooks. That nicely coincides with they already use the existing Android HAL, which is why we get Android support and Chrome support. Vendors such as Raspberry Pi and NXP are helping us as early adopters on the vendor side. I would love to see more vendors. And software companies such as Collabora, Red Hat, and Pengutronics have all worked with us on the software side. So thank you everybody for all of the continual contributions. Almost. So in summary, cameras have got complex. And we need to improve that to get our cameras working on devices that we buy and own. Libcamera is helping there, but there's still a way to go to improve application support. PipeWire, I will always highlight as for the desktop environment, is going to be a really good way forward for that. And you can add even more use cases within PipeWire. I was talking to Danny earlier, who made a background blur functionality, and she could integrate that into PipeWire, and then every application you use would have built-in background blur, things like that. There's frameworks there now that will help us add all these functionalities. Python, Rust, C is all on, well, Python's there now. More language bindings are on the way. GStreamer is already functional. So there are lots of ways forward, but I do look forward to more contributions from from externals. Any questions, or if you want to talk to me after or mail me, there's my email address directly. And thank you. Hello.
Hi. What I'm most interested in is the portal interface, because that is basically a stable API.
Yes, it is exactly already stable.
The one you want to use. For me, the use case that solves is because it's a DBus API that I can easily use it in containers where I might not have direct access to the camera nodes. So if I'm using libcamerify, the emulation layer, is that going through the portal, or is that loading the library directly and thus opening the node directly again?
If you're using the portal with Pipe, that will be your...
That is if the application already has support, right? But if I have a legacy application in a container...
I'm afraid I don't think...
Does the emulation layer itself connect to the portal before it goes back? No.
Our libcamerify emulation layer does not, because that only knows how to talk to libcamera.
I think we should get that functionality.
I squealed because PipeWire also have a version of... I think they copied it from us. So I think there is an equivalent there isn't a script called PipeWireify, but maybe somebody should make it. So there is a v4l2 wrapper in PipeWire.
Okay.
So that could then go through wrapping your application to talk to PipeWire, which would then talk to the portal, which would then talk to Libcamera, which would then talk to the hardware. There's so many layers.
But that's the chain that I want to see.
Yes. So yes, I believe what you're interested in there is an equivalent v4l2 wrapper for PipeWire. And it exists, but it maybe is not. It needs more polish.
Okay, cool.
Hello.
Hi. Have you using v4l2 loopback devices as sort of a way of supporting everything?
Oh, somebody said it. Yes, I'm very acutely aware of v4l2 loopback. So v4l2 loopback is a way of providing a kernel interface that you can put pictures into, and then it creates a video device like v4l2 dev video 0 that applications can, whatever you put in gets read out by an application. There are technical and political reasons why I don't like that, and why there's a specific reasons why it is not upstream. v4l2 loopback has never been accepted into a mainline kernel for various of those reasons. Like I say, some of them are more political than technical, which is painful, but that's why. The Surface devices that we have, they are currently using a v4l2 loopback implementation, and they set up a v4l2 loopback. They use a GStreamer pipeline to use Libcamera. They take Libcamera stream through GStreamer into the v4l2 loopback input. That means they can use existing applications through that. There are more complexities on that. There's more copying, potentially. There's lots of reasons why I want to move away from it wherever possible. It is a current workaround. It's not, in my view, a long-term solution. I'm going to work left to right from my point of view, so...
Not exactly a question to you, but maybe to Canonical folks here. Does anyone know whether Snap Snaps actually do connect the camera device portals? Because it's just a discussion.
So the question is, do snaps support a camera portal? I don't know yet.
It's got access to that specifically. It should have access to the forms. I don't know if it currently identifies applications or not. So I don't know how all the security is affecting that.
PipeWire talks to the permission support.
I think it would factors of trust.
Yeah, the question is, do you think it should be?
As far as I can see, Snapd has some interfaces for stuff that is camera/portal related. This is my best effort answer.
So just for the recording, the question was, do snaps have PipeWire integration, portal integration? And the answer is maybe.
There's probably a further layer of security, like at Snap level you can block or not react.
Yeah.
That's cool.
It's something we've definitely got to address.
Yeah. And then, sorry, moving along, there was another question.
The cameras you have all mentioned are all nearline cameras.
Sorry, there.
They're nearline cameras, directly attached. Do you have any interest in Ethernet attached cameras?
This does come up, so the question is, do we have interest in cameras that are not connected directly to the CPU? Currently, I would say that's out of scope for Libcamera. The Libcamera's goal is to fix the nearline cameras with CSI and MIPI CSI connections and an ISP. It's about managing the complexity that's now required to run on that CPU. My view differs from other members of the team, and I think, yes, we should ultimately have better support and integration for cameras. The name is generic Libcamera, and I think that should cover more things. We already support UVC, for example, and if we covered other use cases, I think that would help. But the official line is it's out of scope for Libcamera. So in the future, maybe, but not now. Hello.
I was wondering about devices that have an accelerometer. If there is any plan for this year, when could you see things happening in the stack about doing ones or tablets or mobile phones, where you rotate the device
Okay.
and you have to rotate the output, but you also need to rotate the input.
Yeah, so the question is about if we can use accelerometers to detect the orientation of devices. We already have controls to support rotation of the image and flipping the image if necessary. So the layers at Libcamera are already there. That an application that would know I want to flip or rotate that image could do that. I don't know if that would be a responsibility of Libcamera or if it's the desktop integration that says, hey, my whole device is rotated, I want to do something about it. I'm not certain that it would be the responsibility of Libcamera to know that the device has changed
That is the
orientation.
That's already not the application state of.
Yeah.
So it would be nice to
Yeah. So,
know which is like a corner or something like
so Libcamera can certainly set controls to rotate the image if the underlying hardware supports it, but somebody has to tell us to do it. I don't think Libcamera would ever implicitly go looking at all the state of the sensors.
I thought GNOME already has support for rotation.
that.
Yeah.
Only outputs, not inputs. So if you rotate the laptop or the tablet, you will get the rotated desktop, but you will get your head.
So interestingly there, I think then GNOME should be talking to the camera portal and there should be a control to then tell PipeWire to rotate the image, which would then tell Libcamera to rotate the image. Hello.
If you're accessing the camera via the portal and the PipeWire stuff, how do you envision you control like specific camera components, like focus tracking and stuff like that? Will it go through PipeWire or something like that?
That is under active development at the moment, I am led to believe. I don't develop PipeWire myself, but Wim Taemans, I hope I've said his name right, he used to help develop GStreamer. He moved on to PipeWire, and I heard from him directly that he's working on adding control support to the camera portal essentially, which would then follow down into Libcamera. So that functionality should be being implemented and available soon.
I can actually answer that because I'm attached to that for PipeWire. It's in PipeWire, and you basically negotiate a stream for the camera, and it applies when you negotiate.
Will it change like where you put the focus and stuff like this?
Yeah.
Because you're finding like a negotiation parameters.
You negotiate, get the parameters from the camera, negotiate again if you need so. And if you change something, you continue negotiating until you get.
So the answer is yes, PipeWire will support
PipeWire
changing the parameters of the camera.
Yes.
Okay, good. Any more? No? Okay, well, thank you for listening to me. And I'm here today and tomorrow, so if you want to talk more about development or find me, just pin me down. I'm very happy to talk about cameras all day long, and there's far more that I could talk about than I could fit in the slide material that I've got here, so thank you very much.